Tonight's video is section 4.4 yet again. We're going to be dealing with the second fundamental theorem of calculus, also the mean value theorem for integrals. We've already done the mean value theorem for derivatives, now for integrals. So the homework assignment is from 43 to 46 all and 81 to 92 all. So let's do the mean value theorem for integrals first, which in other words is finding the c. And I'll show you a picture of that in a moment. If my function f is continuous on the closed interval from a to b, then there exists some c in that closed interval from a to b such that the antiderivative from a to b of f of x of dx equals f of c times b minus a. And so remember, the antiderivative is area. So this could be length and this could be width. So let's take a look at this. Here is a picture. Here is my function f, and it is from a to b, and again it's a curve. We don't have an area formula for that curve, so we could do a right or a left Riemann sum to figure out the area. We could do trapezoidal. What we are going to do is, for the mean value theorem, there is some c in this closed interval from a to b where this c is on the function f, and it's a point where if I make a horizontal line through that value, then I can take the area from a to b and this height, and that area of that rectangle will approximate the area underneath the curve to the x-axis. So last time in 4.4, when we were finding the average value, we were actually finding that y value. Now what we're going to do for the mean value theorem is we're actually finding the c. That is the point on the curve in which the y goes through, that y value, that average value that we already know how to do. So you've already tested on that Friday. So you found this y value, the average value. So we already know how to do that. Now what we're going to do is we're going to find the c value for this ordered pair. This ordered pair here is cy. This is average value. This is mean value theorem for integrals. And so we're going to find it right there. So let's do an example. And just a minute, let me find it. There it is. And I actually chose one of your homework problems, and it's the hardest one and the most difficult just because of the lengthy algebra. So let's take a look at this problem. So use the mean value theorem for integrals to find my c, my x, that lies somewhere between 0 and 2. So when I do 0 to 2, and then I find this c value, and I go up to the graph, again, my a and my b, and I have some c when I go up to the function, that will allow me to take the area, and that area will match what is underneath the curve. So in the mean value theorem, it asks us to go ahead and define this c, go ahead and take the antiderivative from 0 to 2 of this function, so we know how to do that. Let's continue on. So we plug in 2 for x. Oops, sorry, we clean that up. And then I'm going to plug in 2 for x, and when I put 0 in for x, the second one is 0. And so we just clean up that evaluation. I know sometimes we have a hard time with this exponent of 3/2. So there's two 2's. One of them cancel out with that denominator, so there's 1 2 left. Minus, I wrote down my 4/3, and then I broke up this 3/2. When the bases are the same, you add up the exponents. So 2 over 2 and 1/2 is 3/2. So 2 to the first power times 2 to the 1/2 power. In other words, 2 minus 4/3, that's a 2, and that's a square root of 2. I can clean that up just a little bit further. That's 2 minus 8/3 times the square root of 2. So for the mean value theorem, all I have done so far is this side. I've actually taken this antiderivative. Now I'm going to set it equal to this in order to what? To find that C, that value in between B to A. So let's go ahead and let's do that. So you see here's this side, and I set it equal to f of c, and there's my b minus a. My b minus a back at the original problem is 2 minus 0. And we're going to find this c. So f of c, that means go back to my original function f and plug in c wherever I see an x. So that would be c minus 2 square root of c. That's where I got that from. That 2 is from 2 minus 0. That's 2 times this function. And that I just copied. Again, I'm going to solve for c. And the first thing I'm going to do is I'm going to divide both sides by 2. So I divided by 2. That's gone. I divide by 2. I divide by 2. So I have c's in 2 different places. So if I wrote this out a little bit differently, that's c minus 2 to the c to the 1/2. That is looking very similar to a quadratic. We're used to seeing quadratics like this, right, where the power is cut in half. You know, sometimes we have seen them like this. That's still a quadratic form. So what I'm going to do is I'm going to go up here and I'm going to focus that. That looks like kind of like a quadratic form, and I'm going to complete the square. And let's see what happens. Complete the square of the left-hand side. So in order to complete the square, I'm going to scoot that over. I'm going to take this middle term, the b, the negative 2, cut it in half, it'll be negative 1, and square it. What I do to one side, I must do to the other side. Well, 1 and 1 is 2. I just copy that down. Now I'm going to complete the square. So here's my square. Square of square root of c minus 1 quantity squared. And let me multiply that out to show you. So that is c minus square root of c minus square root of c plus 1. C, and there's 2 of these. That does go back to the original. I know we're not used to seeing completing the square when it's just a c to the first power, and this is a c to the square to the 1/2 power. So now I've completed the square. I'm trying to get to that c. I've got this down from 2 c's to 1 c. That's why I completed the square. Now to get to that c, the first thing I'm going to do is I'm going to take the square root of both sides. When I take the square root of both sides, there's a plus minus. Sorry, I don't mean to get that out of your way. So this square will undo this square root. And this is still my plus minus the square root of all this. And yes, you can have a square root with a square root. Now I'm going to add the 1. I just put the 1 in front. Now I'm trying to get to this c underneath the square root. The way to undo that is to square both sides. And again, I know this is nasty algebra, that's why I chose to do this for you. But you need to work through it so you know how to do it also. So I just copied this down, and here's my c. I went ahead and I threw that in my calculator, and I got 2 outputs. Now we got so caught up in the algebra. The algebra was quite difficult. I did not find it easy myself either. I had to really think about completing the square. I want to show you what I did. I have this app. Let's see if I can get you to see this. I'm not sure if I can. Oh, there we go. So there's x minus, let's see, how can I do this? I apologize. X minus 2 times the square root of x. That's my original function. Let me scoot that down on the paper. X minus 2 times the square root of x, which is what I wrote. And why I put that in there is so that I can graph this. Okay, I'm going to go down to my c value. Let's see if we can see that graph. Let me try turning off that light. Nope, that didn't help, did it? Well, you can see it, I think, close enough. And here are my two C values, which are between my A and my B. My A and my B are between 0 and 2. My A was 0, my B was 2. And so my two C values are 0.4. We'll see if that's 1, that's 0.5. So somewhere here, there's my C value, or 1.79, so almost to 2. So that would be my C value here or here. So that when I went up to the graph, all I have to do is make a rectangle. I'm sorry, that is just not showing up very well, is it? I'm going to have to find a different product for me to show graphs. Yep, not working. Well, let me just now hand sketch it out because it's not working. But I want you to see what we got. So what I was trying to show you, negative 1 and 2, and the graph, let's see, actually goes through at 4. So it kind of, let's see, comes around and then goes straight through. And so our two values at about 0.43 at this value, or 1.79 maybe at this value, which like they could be the same, that if I went across, that average value, which we found last week, is this y value here. There's my average value. I'm not finding the y part. I'm finding the x part, which is called my c. I'm sorry, not this one. My c is here, 0.4380 or 1.79. I have my two c values. So now I can find the area underneath that curve. And obviously that area would be negative. Thank you for allowing me to do that. Let's go on to the next part. There we go. Here comes the second fundamental theorem of calculus. If f is continuous on an open interval, we'll call that I, and this I contains a, then for every x in I, here is the second fundamental theorem of calculus. Look at this. I'm going to take the derivative of the integral. So this undoes this. It's something similar to when I have the square root and then I go and I square it. How these two undo each other and I get back to the x. So I usually take the derivative to get a function, and then I take the antiderivative to go back to the original function. Well, I'm going to take the derivative and the antiderivative both at the same time. So they undo each other. They just undo each other. And so how am I going to do this? Take the derivative and then the antiderivative? And before I go any further, the reason we have this is because, look it, up until now, we've had, in fact it says it down here, so far, my b and my a have been constants, have been real numbers. But now, what if b and or a are variables? That's when we're going to use this second fundamental theorem of calculus. That's why I have to use it. Otherwise, I don't need to use this. But if b and or a are variables like this, here I put in a variable. I didn't write from b to a. I put in an x. How am I going to do that? How am I going to do this fundamental theorem of calculus, the second one? So I'm going to go and take my function, this function here, and I'm going to replace the variable with whatever this is, x, and I'm going to take the derivative times the derivative of this b value, which is x, with respect to x. Minus, I'm going to get to this one next. I'm going to take this same f function, substitute in the a, exactly what it is, and I'm going to take the derivative of this a with respect to t. I'm sorry, with respect to x. Apologize, respect to x. I'm not going to go ahead and take the antiderivative. Do you notice I'm not taking the antiderivative? They're the same thing. I'm just, instead of t, I'm putting in x. Because when I take the antiderivative and then go and take the derivative, they go back to the original. The original what? This function. The only thing I have to do is take the derivative of this minus, substitute in a, this bottom value, into this function, times the derivative of this bottom one. And I will prove to you that it does work. Not on this problem, but on the next problem. I just want to work through a problem, and then on the next problem I'll prove it to you. So in 81, capital F of x equals this. So this is the antiderivative. From x to negative 2 to t squared minus 2t dt. I'm supposed to find the first derivative of f of x. In other words, take the second fundamental theorem of calculus. After I go and I take the antiderivative, then I go back and I take the derivative. Well, how am I going to do that? Well, what I just did here. And I just wrote that in words. So I'm going to find the derivative of the integral. In other words, find the antiderivative, then take the derivative, or I'm going to use this, or use the second fundamental theorem of calculus. I'm going to show you this. So again, I just rewrote it, and then it tells me to take this function here and replace it with this b value. So x squared minus 2x times the derivative of x with respect to, again, x, not t. Minus, now I'm going to go down this bottom value. I'm going to take this same function, wherever I see a t, I'm going to put in my negative 2. So negative 2 quantity squared minus 2 times negative 2 times the derivative of negative 2 with respect to x. Sorry, I got t happy. So this just gets copied. The derivative of x, well, taking the derivative, remember you decrease it, is just 1. Minus, let's see, negative 2 squared is a 4. Negative 2 is plus 4. And the derivative of a constant is 0. So this whole side goes to 0. So it's just x squared minus 2x happens to be the first derivative of this. Next problem, and last problem for tonight. Number 87, and I'm actually choosing homework problems. Capital F of x from x plus 2 to x. Again, not constants. So I have to use the second fundamental theorem of calculus. Here's my function, 4t plus 1 dt. Notice these variables do not match. So what does it tell me to do in second fundamental theorem of calculus? I'm going to put in x plus 2 wherever I see t into this equation. So 4 times x plus 2 plus 1 times the derivative of this upper bound, the derivative of x plus 2 with respect to x. Minus, I'm going to go down here, I'm going to put in x wherever I see t into that function. So minus 4x plus 1 times the derivative of this lower bound, which is my x. Now let's just go and let's clean this up. 4 times x is 4x, 4 times 2 is 8, plus 1. So the derivative of x plus 2, remember x just turns to 1 and 2 is just 0. So that would be times 1. Minus, I'm going to copy that down, the derivative of x is just 1. Let's continue to clean that up. So that's 4x, and that's 9. This is minus 4x, minus 1. The 4x's cancel, and then a 9 and a negative 1, the answer is 8. Now let me prove to you by actually doing it the long way, which is not what I want you to do. I'm just doing this to prove it to you. I'm going to actually go and I'm going to actually take the antiderivative, find this, and this here happens to be now the first derivative. So I'm undoing it. I'm going to go and take the antiderivative. The antiderivative is f of x. Now I'm going to go find the first derivative of f of x is 8. So I undid each other. Let me prove that to you down here. Here's the same thing, except I'm going to go ahead and do the long way. I'm going to go ahead and take the antiderivative. So 4t squared over 2 plus t with from x plus 2 to x. Now I'm going to put in x plus 2 in here and then put in x. So I clean that up, that's 2. X plus 2 quantity squared plus x plus 2. So I just did that with x plus 2. Here's my minus. Now I'm going to put in x. So that, remember, that's just a 2. So x, 2 times x squared plus x. So now I'm going to clean that up. I'm still working on the antiderivative and cleaning that up. So that's x plus 2 times x plus 2, so I get x squared plus 4x plus 4, still all times by 2. Copy down my plus x plus 2, distribute my negative, negative 2x squared, negative x. I'm going to continue to clean this up. I have to go ahead and I have to do distribute that 2x squared, 8x, 8, copy, copy, copy. Now clean up. Let's see, the 2x squares cancel. What else? Something else cancels in here. I think that's it. So I have an 8x. Oh, here. There's an x and there's an x. So 8x and 8 and 2 would be, 10. So now let's go ahead, and I'm supposed to be finding the first derivative. So now let's take the first derivative of this. So the derivative of 8x plus 10 is just 8, which was what we got before. Thank you.